So we make sure that the x's and the y's are directly under each other. Occasionally, you may run into a problem where the x and y get flipped just to see if you're paying attention. So that's normally just a quick thing. So step 1 isn't really much of anything. Okay, step 2. Multiply one or both equations by a number to result in a variable with the same coefficient. In other words, check, add down, and see if you can eliminate something. So we're going to add something in here. We're going to add step 2a, which is, can I add down and eliminate a variable? Because this is called elimination. We need, I don't even want to say we need a variable to go away, because if it doesn't, it's kind of hard to solve these. So our first step each time is going to look and say, hey, if I add down right now, well, 1 plus 1 is 2x. That didn't wipe out. 7 minus 1 is 6. Okay, it didn't in this first case, so I cannot add down. So now, here's how we do the multiply part. Then you look at your variables and you go, okay, x's, let's say in this instance. These x's each have a 1 in front of them, so does this y right here. I like to deal with ones when I see a variable that has 1 positive and 1 negative. So I see positive and negative with y's. So here's the question. Can I multiply 1 by something and get to 7? 1 times 7 would get me to 7. You're like, okay, so why would I do that? Check this out. I'm going to copy this one over. But this one down in the bottom, that's 7, I'm going to multiply that through. I'm going to distribute that through to all of these. So I'm going to have 7x minus 7y, because 7 times negative 1 is negative 7, equals negative 49. Now if I go through and add down. Okay, so that was step 2 we just did. This now is going to be step 3. When we add down, 1 plus 7 is 8. 7 plus negative 7 cancels. There's our elimination that we were trying to get. And 17 and negative 49 is negative 32. So all of a sudden, we have gone from 2 equations with 2 variables to 1 equation with 1 variable that we now can solve for. So there's my first answer. That was step 4. You're like, just with this, we're already 4 steps deep. We got 1 step to go. Substitute your answer from step 4 into either original equation to find the other variable. Okay, I always just tend to use the top equation. That's just me, though. So step 5, I'm going to start writing this equation. But like here with that x, I'm going to replace it with its value. So that's going to be negative 4 plus 7y equals 17. So I replaced the x with its value. Sort of like when we were doing the substitution stuff yesterday. And now we're just going to solve our 2-step equation. And get to our answer. So basically what we're doing is we've got 2 separate equations that we're dealing with to get to our 2 variables, which makes sense that each equation is going to need its own. And so that is like a medium range amount of work that we're going to see on one of these. Now, we're always hopeful, though, that we get one like number 2. Because I'm always going to look first before I do anything and ask myself, okay, if I add up, am I going to get rid of a variable?
3 plus 5 does not cancel. 2 plus negative 2, that sure as heck cancels, though. So again, we're skipping the first 2 steps. Didn't need them. Okay, we're already to step 3, and we barely had to do anything already. I do my 1 step to solve. There's my step 4. So I've got the x equals. And then again, for step 5, your pick. Either one of those original equations, again, you're going to see Hardy more times than not. I'm just going to plug it back in to the top one. Even if I plugged it into the bottom one, I would get the exact same answer. So let's see here. We want to get y by itself. So we're adding 24 to it, so we got to subtract that out. And most of the time when we do these, I won't say every time, most of the time when we do these, we're going to get whole number answers. I am going to do an example with you where you don't get a whole number answer, but I also don't want to go crazy into overkill mode here with some of this stuff. So what we're basically going to see with most of these, I'm just looking to see, okay. I want to make sure I don't go overkill, but at the same time, I want to make sure we can see what happens with these. So I got 2 more here I want to do. I want to do 3 and 6. If I got to come back later and do some more, I can. So I look. Can I add down and get rid of a variable right away? 4 plus 1 is 5. Negative 9 plus 5, no, that's not going to work. Okay. When that doesn't work, we just start with our first variable. You look at the smaller number, which is 1 in this case. You say, hey, can I multiply that number by something to get the number above it or below it? It's a whole number. If the answer is yes, and it is this time, we're going to multiply by that number because 4 times 1 is 4. But we've also seen they need to be opposites. This is positive 4. 4 times 1 would be positive 4. That's no good. So this time it's going to have to be negative that we multiply by. And we'll see in just a second when we rewrite this. We're going to distribute that negative 4 to all 3 terms. And then just add down. Nothing wrong with using the calculator on some things if you need it. Work my way to that first answer. So again, step 2 we were good. Step 3, step 4. Last step again, either equation, Hardy's boring. I always do the top, even though I think that's the trickier one in this case, but that's okay. Just substitute the number. It's y equals, so make sure it goes in for y and not x. Multiply those up. Add that 18 over. Okay. Divide by 4. So more times than not, you are going to end up with saying, sometimes I can add down, sometimes I got to multiply by one equation. Every once in a while, we're going to run into one other thing. We're going to run into a situation like number 5, where you're like, all right, no, that don't cancel. Okay, no canceling this time. Can I multiply by 2 by a whole number and get 5? No, like 2.5, that's no fun. Can I multiply 3 by a number and get to 7? Uh-oh. No. So, like, do we just get to skip this? No. So we're going to pull the old switcheroo. So here we go. Watch this move. So you see how this starts with 2 and this starts with 5? This 2 is going to the top. It's frozen still. What the heck? What the heck? All right, so let's try that again in real time. I'm basically going to take these lead coefficients for x, and I'm just switching them. So the 2 comes out here, 5 comes out here, and since they're both positive right now, I don't want 10 and 10. That'd add up to 20. So I'm just going to make this bottom one negative. Like, Hardy, you're just making stuff up as you go. Not really. Because watch how what I just did works out nicely here. So we're multiplying each of these by 2. Down here, we're multiplying each of these by -5. Make sure it's all of them. Don't forget that number on the end. It's every bit as important as the other 2. X's go bye-bye. 10 and -10. Add down for my y's. Add down for my coefficients. Okay, my regular numbers here. And I get a really nice number out. So now everything's pretty normal. My last step here, you know where I'm going, right back to the top. I'm copying until I get to the variable that I solved for. So y is actually 1, so we'll put that in there. So 3 times 1 is 3. We're going to minus that 3 out. And we're going to divide by 5. And we're starting to feel kind of confident here. We're like, okay, I mean, we're getting whole number answers. I could check them back in if I really wanted to, or I could use Hardy's key and check when I'm done. But we haven't run into the weird yet. You're like, okay, what's the weird? The weird is when we run into one where, like, all of our variables are canceled, or something's just doesn't seem right. So I want to do one that's that way. We're going to use number 5 as our example. We're going to ride this exactly the same way. So here, this 3 and this 4 are going to flop. So 3 to the bottom, 4 to the top. Wish I had left more room between the number. That is not 64. It's just by 4 that I'm writing. And I'm going to have to remind myself here in a minute. When I get down here to the bottom, I don't want it to be just plain old 3. Because 3 times 4 would be 12. 12 and 12 does not cancel, but 12 and -12 does. So if I move -3 all the way through, and then weird is about to happen. So I do all my proper multiplying through. 12x and -12x, see you later. Ooh, -36, +36, y, see you later. Okay, that's kind of interesting. 36 minus 108 is negative 72. Last I checked, 0 does not equal negative 72. That is false. So we get no solution. If I'd have gotten, let's say, 0 equals 0, that's true. That'd be like infinite solutions. So that can happen here now and then. You just got to be careful when all the variables go away. It's going to be one of those two special cases. You're like, okay, livable, Hardy, livable. Terrific. We'll be all right. So, here's the thing. You're like, Hardy, don't do it. Don't do it, Hardy. We're going to do it. We're going to do a couple. I'm not going to go crazy. Sure. Listen, who needs them? You're like, oh boy. Hardy, now you're putting words with things. This is not cool. Okay. I'm only going to have you go through 2 of these. Just 2. Just 2. Remember, this is the last new lesson stuff of the week. So, hey, we're going to be all right. So, okay, define our variables. What are we solving for? 2 equations, solve the system using the method of your choice. Okay. So Marcy bought some used books and CDs during a yard sale. Dang, CDs. For a total of $54.50. If the books cost $150 each and the CDs cost $5, how many of each did she buy? Okay, time for me to use my colors. Books cost $1.50 each. CDs cost $5 each. So here's my first thing. I need to explain what my variables are going to be. Bless you. Me, I like to use variables that are like the words I'm dealing with. So I like to use B for books and C for CDs. If you want to use X and Y for everything, you could. Okay, Hardy, so what good did that do for me? So here's the next thing. Everything that has to do with money, we're going to put together an equation. So, books cost $1.50 each. So $1.50 times each book. Okay, that's money. And CDs are $5 each. So C times $5. What's the other money thing in this problem? What other value is there with money? The total. So there's one of my equations. You're like, well, where am I going to get the other equation from? I look around, are there any more numbers here? Marcy bought a total of 20 used books and CDs. If B is the number of books, and C is the number of CDs, and she bought a total of 20. That's what we've got rolling here. We've got our equation set up. We're set and ready to go. Now, this isn't the most fun one to deal with, but again, if you don't want to deal with a decimal, you're like, okay, come over here to C. What do you multiply 1 by to get to 5? That's what we're going to do. But positive 5 and positive 5 cancel? Got to do negative. Make sure I stay on the screen here. So that negative 5 goes all the way through. I would absolutely suggest a calculator on this one. Dealing with decimals and negatives, yeah, that's asking for trouble if we don't. I'm even busting out one here for the end part. So she bought 13 books. I'm not going back to that equation. I know. I said I always go to the top equation. I'm not going to the top equation. I'm coming back here. B plus C equals 20. Subtract the 13. So the only difference is we're setting up the problem, then going through to solve it, instead of just taking what they give us and working it through. These two we're going to do, 9 and 10, are closest to what you're going to see with the majority of this. And I'll jump in and help you with setup on some if that's where your trouble spot is. Last one. Oh, last regular listener to Hardy for the week. All right, let's see what we can find. Landon babysits and works part-time at the water park over the summer. 1 week he babysat for 3 hours and worked at the water park for 10 and made 109. The next week, he babysat for 8 hours and worked at the water park for 12 hours and made 177. Landon needs to find out better paying jobs. How much does Landon make per hour at each job? So it looks like we got babysitting in the water park here. So now this one works a little differently because I start reading through this and it said, okay, 1 week he babysat for 3 hours, so that'd be 3B, and worked at the water park for 10 hours, that'd be 10W, and made $109. Okay, so there's an equation. Right in the sentence, there's an equation. The next week, he babysat for 8 hours, worked at the water park for 12 hours, okay, and made $177. How much do you make per hour at each job? Okay, I got something to work with now. The only bad news is I can't multiply 3 by a whole number to get 8. It's a decimal or a fraction. And I can't multiply 10 by a whole number to get 12. So, flipperoo, here we go. Take those two lead coefficients, switch them, and if one of them is not negative, and neither is this time, we're going to make one of them negative. It matters nothing which one you do it negative with. And we're going to distribute that 8 on top. Ooh, that's a big number. And we're going to distribute that negative 3 on the bottom. Don't think I trust myself on that. Let's try. Oh, I was right. So B's have gone away. $341 divided by 44. Uh-oh, Hardy, we got a decimal. What did we do wrong? We didn't do anything wrong. We're talking about money. You can get cents. So at the water park, Landon was making $7.75 an hour. Oh, Landon. And then again, to figure out the babysitting, just pick your favorite equation. 3B plus 10W equals 109. Why did I write so low? I don't know. All right, let's see here. Got to subtract the 7750. That's 3150. Oh, why didn't I write over further? Oh, this is going to be even crazier. Maybe not. Hey, at least he made more babysitting. 1050 an hour babysitting. That don't seem like enough either. So
with some of the equations, you may have to dig a little more like you did with 9 to get what you're looking for. But oftentimes you do these, the equations are going to be right in the sentences for you if you just line them up as you're going. So now I can kind of give you an outlook for the rest of the week here. I'll put this back in a minute. So in the practice, let's go odds in the practice on 7 through 9. Let's go odds. That's going to be like a grand total of what, 8, like 8 problems total. And what we'll do tomorrow